I hope you guys have followed my previous lectures in the for the object code generation for SIC programs. If you have followed my previous examples, so then understanding this will be a bit easy. So if you have not understood the previous examples, so because this in this program where we'll be having all the different cases. Okay, in the previous examples whatever we discussed, so I had given a level by level or step by step, I can tell you, whereas in this example we are going to have all the different cases. So before I take you to the object code generation directly, so let me tell you something related to this particular program. If you ever remembered, we have discussed the same program in SIC as well. So there are only few changes. Okay, even if you want me to, or if you guys want the theoretical explanation of the program, you can refer my SIC example. So here I'm not going to explain the program again. So instead of that, I'll be just telling you what are all the different changes. Okay, so we are getting here. First and foremost thing, this is where you can observe this is a kind of format for instruction. Okay, and this is immediate addressing mode, and this is as usual a base register for holding the data of address of the length. In the base register we are using a base. Then again here we have immediate addressing mode, so this is again format for, and here is immediate format for, like that whatever it is different. So the only those things let me highlight. And I hope I told you so many times that if your operand is preceded with the hash, then it is the immediate addressing mode. If the operand is preceded with the at the rate like this, it is a indirect addressing mode, for which you'll be setting n to be 1 and I to be 0. Okay, for these immediate addressing mode, what you used to set n as 0 and I as 1. So whereas for indirect, so how to identify indirect instructions in the sense, so in the instruction, if any operand has is preceded with and starts with the at the rate symbol, so it is belongs to the indirect addressing mode, for which you need to set n as 1 and I as 0. Okay, again here you can observe these are the format 2 instructions which are working purely on the registers only. Okay, the format to instructions which are working only on the registers. Then again here you have which is format 4 and also the immediate addressing mode. So again here we have one more register which is working purely on the registers, which is E and the S are the registers, so it is again format 2. And here again we have one more instruction TXRT, which is format 2 instruction, right? And this is the one of the instruction which belongs to the indexing, because it is making use of X register. Then again if I keep going further, so again here is one more instruction making use of X register, so it is a indexing addressing mode, right? So again here we have format 2 instruction which is working purely on the register. So likewise you'll have to, what you're supposed to do, first you'll have to identify which are all the instructions belongs to format 3, format 1, format 2 and the 4, right? So you need to identify, based on which itself you will be performing the address assignment. I repeat, based on which itself will be performing the address assignment. Now let us start assigning the address. So here the starting address is what? 0. 0 is the starting address from where you're supposed to start assigning the addresses based on the type of instruction. I repeat, based on the type of instruction you'll be assigning the so and so addresses to the respective instructions. When I say the type of instruction, it can be a format 1, 2, 3 and the 4, or it can be a set of assembly directive instructions like this. So these are the assembly directive instructions for which you'll have to assign the address based on the different scenario. That same story whatever we discussed in the previous examples. Okay, that's what I already mentioned. So if you have understood my previous 4 examples on the SIC XC object code generation, then this will be quite easy, right? Now let me take you to the address assignment. If you ask me the address assignment right here, my dear students, so you can observe, as I said, that we'll be starting with the we'll start assigning the addresses starts from the 0. Okay, start from 0, we'll be starting the address assignment, right? So, and as usual, this is this is not the instruction which is acting only on the register. So this can be a this is one which is acting on the memory space, so it can be format 3 or 4. Again I said you, if a opcode is preceded with the plus, then only it is format 3, sorry, format 4. If not, it is format 3. So now it is format 3, so for which will be assigning 3 bytes, so the next address would be 3. Again LDB hash length, which is immediate address mode, and it is again a format 3. So next address would be 6, and again in my previous example itself I quoted that. So this is the instruction which is a base instruction will not be executed. This is only to indicate that address of the variable length, I repeat, address of the variable length will be stored in the base register. So you don't have to assign any address for this instruction, which is a base length. You don't have to assign any memory space. At the same time, you don't have to generate any object code for that, because it is only, it is just like as same as comment line. Okay, so you don't have to assign any address, or you don't have to generate the object code for the base instruction. Then again here we have plus. So as it is a plus rate record, so which requires 4 bytes, so the next address would be 000a. So because 6 plus 4 is 10, 10 is nothing as a. Again you have LDA length, which is format 3, compares hash 0, which is format 3, JEQ and fill, which is format 3. So only you'll be implementing 3. A plus 3 it is D, D plus 3 is 10, 10 plus 3 is 13. Again we got one more instruction, which is plus J sub. So as it is plus JSON, again it is a format 4, so for which will be assigning 4 bytes. So next address would become 17 instead of the 16, right? Again we have JSC loop, LDA, STA buffer, LDA hash 3. I hope you guys are following me. So all these are all the instructions belongs to format 3, so for which will be just assigning the 3 bytes to each. And when it comes to plus JSF rate record, again we need to allocate 4 bytes, so only it is 26 plus 4, so it will be a 2a. 26 plus 4 it is 2a, because we'll be assigning the 4 bytes. Then again you have j at the rate return address. So this may be indirect address, but it is a format 3 instruction itself, so for which we'll be assigning only 3 bytes. So 2a plus 3 it is 2d, right? Now from here it is the assembly directory instructions. It is neither, you can't say that format 1 2 3 4. Those are these are the set of assembly directory instructions for which you need to assign the addresses based on the operands. First and foremost thing, which is byte. As I mentioned so many times in my previous examples as well, for the byte instruction you will have to assign the address based on the length of the operand. Here the length of the operand is 3. You can observe there are 3 characters, which is E, O and the F. There are 3 characters which are mentioned as E, O, F, and those are characters. And in our SIC or SIC for each character you will have to assign, or I mean say characters will be represented in SIC or SIC by using the ASCII codes, and for each ASCII code you need 1 byte. So to represent 3 characters you need the 3 bytes. So that means a 2d plus 3 it will become 30. Students, am I getting this? Sorry, are you understanding this? For this byte, any doubts? Like I hope did you understand how did you get this 3? Why you are allocating 3 bytes to this UOF? It is because of, so you need to allocate based on the C. I hope you remembered. If you remembered, we have discussed this so many times that, like if it is a word instruction irrespective of the operand, okay, if it is a word instruction irrespective of the operand, you will have to allocate only 3 bytes. Whereas for in case of a byte, so you first need to identify the length of the operand. So here there may be only three characters, which is EOF. Okay, in this case it is maybe only EOF, only 3 characters may be there. Per suppose if you take up an example like Bengaluru, if suppose instead of this UOF, if it has Bengaluru, so that Bengaluru BNGALURU, so which has totally 9 characters. So in such case you will have to allocate 9 bytes. Okay, in such case you will have to allocate 9 bytes. So only we say that in case with respect to the byte, first we have to identify the length of the operand, based on which itself you need to allocate the memory space. Then again we have reserved word 1, reserved word 1. So for reserved word 1 means 1 word you need to allocate for each. So only it is that you will be allocating 3. And when it comes to buffer reserved byte 4096, this story again we discussed in case of in case of SIC. So I told you. So as it is reserved byte 4096, so you will be allocating 4096 bytes. Okay, I repeat, you will be allocating 4096 bytes. So this 0036, whatever you have, for which you will have to add 4096, but this 0036 is in the hexadecimal and this 4096 is in the decimal. So first you should convert this 4096 into the hexadecimal. When you convert 4096 into the hexadecimal, it will become 1000. When you add 1000 to the 0036, it will become
1036. It will become 1036. Students, is it clear how we are getting 1036 here from the 0036?
Yes, sir.
Yes, sir.
So the reason is that, so here reserve byte 4096. See, if it is reserve byte 1000, let's assume reserve byte 1000 means 1000 bytes only, but that 1000 first you should convert to the hexadecimal that you supposed to add. Here the value is 4096. When you convert that 4096 into the hexadecimal, it will become 1000. That 1000 I am adding with the 0036. So it is become as 1036. Again, as I mentioned, these are the three instructions which are belongs to the format 2. So only you can observe I am allocating only 2 bytes. So 36 plus 2 is 38, 38 plus 2 is 3a, 3a plus 2 it is 3c. Okay. So likewise, I will be allocating only 2 bytes to each instruction, because those are format 2 instructions. Again, plus LTT, which is a format 4. As it is format 4, definitely you'll be allocating what? As it is a format 4, you will be allocating 4 bytes. So C plus 4, C means nothing else 12. Okay, C is nothing else 12, 12 plus 4 is nothing else 16, 16 is nothing else 10. So it is 3C will become 40. Again, you have TD input, JEQ, RD, all those are format 3. So you'll be allocating only 3 bytes to each. You can observe 4, 40, 43, 46, 49. Okay, 3 bytes to each. Again, we got one more format 2 instruction, which is compare A, comma S. When you say that compare A, comma S, so 9 plus 2, okay, 9 plus 2 is what? 11. 11 is nothing as B, right? Again, you have JEQ, STC buffer, comma X. So all those are format 3, for which you will be allocating 3 bytes. Again, we got one more instruction at the TXRT, which is again format 2, for which you need to allocate 2 bytes. So for 51 plus 2 it has become 53. Again, we have a few more format 3 instructions, for which will be keep allocating the 3 bytes to each. Again, here we got one assembler derivative instruction. I told you in case of byte, how we will be allocating the address. It is purely based on the length of the operand. Here the length of the operand. Here also, when you consider in case of UOF also, length of the operand was 3 byte. How did you say 3 bytes? Because it's a total 3 characters, and each character requires 1 byte, so it is 3 bytes. So here the length is 2. You can observe 2 f and the 1. It has two values, but what kind of values? Those are the hexadecimal values. So for 2 hexadecimal values, how much memory space you need? In the sense, it is purely 1 byte. Because I hope you remembered, even we discussed these kind of examples in the previous sessions as well. For each hexadecimal number, it requires half bytes. So here it is f1. There are 2 hexadecimal numbers. So for both it requires 1 byte, because for each it requires half byte. So in that means what would be the next address? Can anyone of you let me know what would be the next address, students? Yeah guys, what would be the next address? Students, are you understanding?
105D, sir.
So the next address is definitely it is 105D, because where we'll be allocating 1 byte to it, so it will become 105D. Again, it is a clear X is a format 2, for which you need to allocate only 2 bytes. So D plus 2, D is nothing as 13, plus 2 it is 15, so it will become F. Again, we have few format 3 instructions, for which will be just allocating 3 bytes to each. TXRT, which is again format 2, so for which will be allocating 2 bytes, so it will become 6C plus 2, it is 6 E is nothing as 14, 14 plus 2 it is 16, so 16 become 10, so that is what? 70. Again, you have 73. Again, here we got again byte x05, byte x05. So again, there are 2 hexadecimal numbers, which is 0 and the 5. So when it is 0 and the 5, so for which we'll be allocating obviously 1 byte. So what would be the next address? Means it is 1077. I repeat, the last address is 1077. 76 plus 1 is 77. So based on this, can anyone of you let me know what is the length of the program, students? How to find out the length of the program?
1077.
So the length of the program definitely will be 1077, because the last address minus the first address. The last address is 1077 and the first address is what? Zeros. First address is 0. So 1077 minus zeros is what? The total length of the program is 1077. Yes, students, we are done with the address allocation. Now, before we move on to the object code generation, if anybody has any queries, you can ask me. Yeah, so I hope you understood the past one of your assembly, which is address assignment. If you're understood with this, then I can take you to the past two, which is the object code generation. Students, any doubts still here?
No, sir.
Okay, so if that is the case, as I mentioned, so in my previous sessions, I had in the expanded format, I had shown you all those how to fill the each bit and generate the object code. Today I may not be showing you like that, but try to understand. But even if you get any doubts also, no issue, you can let me know at any point of time. Okay, now I'll take you to this yeah, let us start with the object code generation from for each instruction. So if I start with the first instruction, which is STL return address, so it is a format 3 instruction. First point is it is a format 3 instruction, and whenever you'll be writing the opcode, okay, whenever you'll be writing the opcode, so the opcode of your STL, okay, the opcode of your STL is 14. The opcode of STL is 14. When you write 14, did you remember that 1 4 should be written in the how many bits? How many bits you can write that 1 4 in the format 3? What is the length of the opcode in format 3? Yes, students, what is the length of the opcode in the format 3?
6.
Definitely we have to write that 14, which is opcode in the form of 6 bits. So that is followed by you'll be having NXPP. So as we mentioned, this is neither immediate nor indirect. So N and I will be 0 0, sorry, 1 1. N and I will be 1 1. Again, it is not making up any extra register in it. So X will be 0. Again, coming to the PC, B and the P. So how do you find out the address in case of format 3, if you ever remembered? So we need to, what is the, can anyone of you let me know what is the formula to be used to find out the displacement in format 3? All this we discussed in the previous examples. Yes, students, how to find out the displacement in a format 3?
So operand address minus PC value.
Exactly, operand address minus PC value. Here the operand is return address. The address of that RET here it is 0030. You can observe 0030, and for this instruction the PC is 003. So when you subtract 0030 minus 0003, you will get 002D. So that is where you will get this 17, because why it has become 17, as I mentioned, the opcode of STL is 14, but it has become 17. The reason why it has become 17 means, so N and I will be set as 1 1, and so as however P will be set as 1, and 02D is the address. That's how we'll be getting 17202D, right? Next you have LDB hash length. Next you have LDB hash length. Again, it is the immediate addressing mode, for which you'll be setting N as 1, sorry, N as 0, I as 1. I repeat, N is equal to 0, I is equal to 1 for the immediate addressing mode. Whereas in that case, so as usual, we know that, okay, we know that the opcode of the opcode of your LDB, opcode of your LDB is 68. So we'll be writing 6 and 8 will be written as only 10. If you say it is only 10, but again N and I will be set as N will be 0 and I will be 1, followed by you need to find out the displacement. How to find out Operand address minus PC value as usual. What is the operand here? It is a length. Operand is what? Length. It has the address which is 0033 minus, for this the PC value is 6. So 33 minus 6, again it is a 02D. That's why you are getting a 69202D. When it comes to plus JSub read record, as I mentioned, for this base length you don't have to generate any object code as well. Okay, now when I take you to the plus JSub read record, in that case, which is a format 4 instruction, so plus JSub read record. So for the point like JSub, right? So for the JSub the opcode is 48. For the JSub the opcode is 48. We'll be reading as 4 and followed by the 8. How do you write 8 in the 2 bits? It is only 1 0. Followed by, you can observe, it is neither indirect nor immediate. So N and I will be set as 1 1. So that is become 1 0 1 1 will become B. Again next it is, so it is not making use of any index register, so X will be 0, and as it is format 4, you don't have to bother about the B and the P. Directly you need to set as 0 0, and E will be set as 1. That is followed by address. So address, so in case of format 4, direct address will be taken. So what is the address of the read record? It is 1036. Even if you take 1036 also, it will become only of 16 bits, but in the format 4 we have the address filled up totally 20 bits. So this is what the total address field, which is 01036. Right, so that's how we'll be doing for every instruction. You can keep following. So for this, if I take it to the compare hash 0, when I take it to the compare hash 0, again it is a format 3 and immediate. So you need to find out the opcode of compare and followed by, as it is a hash which is immediate, it is a immediate addressing mode. And for the immediate addressing mode, definitely you'll be setting the N as 0 and I is equal to 1, and that is for the displacement. What is displacement? Operand address minus PC value. But what is the operand here? The operand is a 0. I repeat, operand is 0. When the operand is 0, so there won't be any address for that, because the 0 is a constant value. There won't be any memory reference for it. So when it has no memory reference, so the address will remains as zeros only. So BP also will be set as 0 0. That's what you got. 2940s for the compare hash 0. Again you have end fill as usual, format 3. So the you need to find out the operand address, end fill. So end fill, where is end fill? Yeah, here it is, 1001A minus the PC is 0013. So when you subtract 1A minus 13, you'll get 0007. Again, it is neither indirect nor immediate nor indexed. Okay, so it is not indexed as well. So next, if I take you to the plus JSub write record. So as usual, again it is a format 4. You'll be taking the direct address of write record, which is 105D. Even further, you'll be adding 0 more to make it as 20 bits, which is so that it will become 010105D. Like that, we'll be keep going. Students, are you understanding? I may not be expanding and showing you for this, because we have already taken as many as examples in detail. So I'm just showing you only the outline for this. But are you getting, guys?
Yes, sir.
Right, so if I keep going, so whichever is something different there, I will be just highlighting. Okay, here also if you take up J C loop, so as usual, when you find out the displacement, C loop is what? The address of C loop is 006. The address of C loop is 006 and the PC is 001A. When you subtract 6 minus 1A, definitely you will get a negative address. But how to represent negative address, my dear students? How to represent negative numbers? Yes, how to represent negative addresses? Students, am I audible to you all?
Yes, sir.
How to represent negative addresses? We have considered these also in the previous cases, this kind of things.
So take 2's complement, sir.
So definitely, so we need to take this 2's complement. So 6 minus 1A, we will get negative number. When you take this 2's complement, you will get FEC. That's what this FEC. Right, so that's how we'll be keep going. So here again, let me highlight. So the rest of the instructions, normally when we'll be keep doing, let me highlight here something which is J at the rate return address. Okay, this is where I am highlighting. For this, as it is a, you can see at the red symbol you have. So for which n will be equal to 1. So whereas I is a 0. I is equal to 0 and n will be 1 because it is a indirect addressing mode. So throughout in this complete program, you can observe, if you ask me directly, so for this hash instructions will be setting n as 0 and I as 1. Okay, how many hash instructions you have in this program? You can see hash length, hash 0, hash 3. Again, you have hash 4096, right? So those are the instructions for which you'll be setting n as 0 and I as 1. And this is the only instruction in this program where you'll be setting n is equal to 1 and I is equal to 0. Rest for all other instructions you'll be setting both n and I as 1 because all, so when the any instruction is neither indirect nor immediate, so we'll be considering them to be a simple addressing mode for which we'll be setting both n and I as 1 right. In the same way, if you ask me with respect to the indexing addressing, so you can observe, so throughout in all these instructions we are not using any of the, okay, we are not using any of the x register in any of the instructions. So for all these instructions the x will be set as 0 itself. When it comes to this instruction, which is ldch buffer comma x, and also this ldch buffer comma x, these are the two instructions where we are using the x register. So only in these two instructions will be setting x as 1. Rest all other instructions for which x will be set as 0 itself, right? And here when you take up this byte instruction, however we say that your operand itself will act as a object code. Okay, your operand itself will act as object code. Here the operand is what? EOF. So how to consider EOF in the object code format, where will be considering the ASCII. So 45 is the ASCII of E, 4F is the ASCII of O, and 46 is the ASCII of F, right? So that's what the 45, 4F, 46 is the ASCII of EOF. So that's where that 45, 4F, 46 itself will become the object code for EOF. Students, are you understanding? What, Nikita? Nikita, Nithin, Mitesh, Navya.
Yes, sir.
Are you guys are understanding?
Yes, sir. Yes, sir.
Yeah. So moving towards again, here we have the three format 2 instructions. If you ever remembered, what is the format for the format 2 instruction? We have opcode followed by a register 1 and register 2. That's where, and again in the opcode we'll be considering the total 8 bits in the opcode. So that is what clear. The opcode of clear is B4. Okay, clear opcode of clear is B4, and the register number of x is 1, and there is no second register, so it will become 0. Again clear A, B4 is the opcode of clear, right? The register number for the A is 0, there is no second register, so it will become 0. Again clear yes, so B4 is the opcode for the clear, 4 is the register number of yes, and there is no second register, so it will become 0. That's what B440 is the object code for the clear EX. So clear EX, A and the S, those are the format 2 instructions. Then taking you guys to this plus LDT hash 4096. So definitely it is a format 4 instructions, dear students. Plus LDT 4096. Even if you ever remembered in this case, which is plus JSUB read record, also I told you, which is a format 4 instruction, you'll be considering the direct address of this operand. What is operand here? It is a read record. So we consider the direct address of that, which is 1036. But in the instruction plus LDT 4096. Okay, in the instruction plus LDT 4096, you need to consider the direct address of the operand. But what is the operand here? It is the 4096. 4096 itself is the operand, which is again it's a number. It's not the memory space. It is a constant number. So my dear student, that 4096 itself will act as the object code. Sorry, 4096 itself will act as a address, but that 4096 will be representing in the hexadecimal. When you represent 4096 in the hexadecimal, definitely it is a 1000. And again that 1000, if you write 1000, it is again a 16 bits. To make it as 20 bits, we will be writing as 01000. Guys, did you understand this? How you got 01000 as address for this 4096?
Yes, sir.
Because 4096 is the operand. That's true. Operand is 4096. And in case of format 4, definitely you have to consider the direct address of the operand. But here the operand has no address because operand is the direct constant number. It's an integer. So it won't be having any address. So that integer itself will act as the address. So in that perspective itself, that 4096 itself will become the address. But that 4096 will be representing in the hexadecimal. So it will become 1000. And that 1000 is also requires only 16 bits. But you have to make it to be 20 bits, so you are writing as 01000. Right, again moving towards TD input. If you take TD input, definitely you need to find out the address of input. What is the address of input? It is 1005C minus the PC value is 1043, right? 105C minus 1043, that value you are going to get as 019. Again you have R loop. For this you can observe here, right here, R loop. The address of R loop is 1040 minus the PC value is 1046. I repeat, the PC value is 1040. When you do this 1040 minus 1046, you will get minus 6. 1040 minus 1046, you will get minus 6. That when you represent minus 6 in the hexadecimal, you will get as FFA. Right, like that itself will be keep continuing. Again compare A comma S. The opcode of compare is A0. Again you have A, the address, the register number of A is 0 and register number of S is 4. That's how will be keep going. Now I'm taking you guys to the very important step right now. I repeat, this is very important step, my dear students. I'll be showing you with respect to this, because yes, if you ever remembered, I told you that for all these instructions, where and all you'll be setting n as 0, I as 1, where and all you'll be setting n as 1, I as 0, to which are all the instructions you'll be setting both n and I as 1, and which are all the instructions. So these are the two instructions for which you'll be setting x as 1, rest all other instructions x as 0, all that I told you. Even when it comes to B and P as well, even when it comes to B and P as well, for all these instructions we'll be setting P as 1, which is considered that program counter relative. But we have four instruction, we have the different instructions right here, which I'll say that four instructions, these four instructions, I repeat. So whichever I have ticked here, which is stch buffer comma x, stx length, ldt length, LDCH buffer comma x. These are the four instructions which are belongs to the base relative addressing. I repeat, it will belongs to what? Base relative addressing. For your understanding, okay, for your understanding how it is base relative, that let me show you clearly. Before that, so am I clear till here, my dear students? Whatever I told till now.
Yes, sir.
Now let me show you something. So this is again a final the object program. So this I'll just keep it separate. So I want you to see this properly right now. As I told you, this stch buffer comma x, I told you that this is here, this is the instruction which will fall under, I repeat, this will the instruction which will fall under the base relative. I told you how it will become base relative. For that, let me give you some kind of depth explanation about it. So even before that, I hope if you remembered, so the different formats, okay, the different formats of your essays, format 3 and format 4. So I'll be just considering that itself. So if you remember, we have opcode of 6 bits, again followed by n, I, x, b, p, P and the E, followed by the displacement, right? So that this is how we'll be having, right? So this is the I said as displacement. This is the we had, right? So if you ever understand here, try to understand. Let me make it very clear. First let me consider the instruction stch buffer comma x is there, no, that I'll be considering first. Later we'll move on to the further instructions. Now students, I hope my PPT is visible to you all. If not, please ask me. Students, whether my PPT is visible to you all?
Yes, sir.
So here if you observe, which is stch buffer comma x, first I have to find out what opcode of stch, is it not? I have to find out opcode of stch. What is the opcode of stch? Let me find out the opcode of stch. Here you can observe the opcode of stch is 54, but how I have to write? I have to write as 5 and the 4. So I'll write as 5. It is 0 1, 0 1 is 5 and 0 1. I'll just, because I need to write only 6 bits, so I'll write as 54 as 5 and the 4, in the 4 I'll be writing only 0 and the 1. Again if you observe, in this instruction, it is stch buffer comma x, so it is neither indirect nor immediate, so both n and I'll be setting as 1. And you can observe in the instruction I am using the x register as well. I'm using the x register as well, so I'll be setting x also as 1, right? And it's a format 3, so I'll be setting e as 0. Now let me find out the displacement. Let me find out displacement, based on which let us think of setting which, whether it is a b or the p, for which how to find out the displacement. In case if it is a general case is what, how to find out the displacement, I hope you remembered, which is the operand address. I'll simply say the oa minus pc. So if you ever see here, my dear students, it is stch buffer comma x. What is the operand here? It is the buffer is the operand. I repeat, buffer is the operand. Where is the buffer? Buffer is here. What is the address of the buffer? It is 0036. Okay, address of the buffer is what? It is 0036. So operand address is what? It is 0036. 0036 minus PC value. What would be the PC value? What is the PC value? As I am working in this instruction, so the PC value is 1051. I repeat, the PC value is 1051. So it is 1051. When you subtract this 0036 minus 1031, what is the value I'm going to get? Let me show you in the calculator. Students, whatever I'm doing in the slides and also calculator, is it visible to you all?
Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
Now let us let me take you to the let us find out this. Let me switch. Okay, as I have to do the hexadecimal operation, so it is 0036 minus 1051. What is that? What is the value I'm getting? You can observe, my dear students, I'm getting as EFE5. Okay, I repeat, it is EFE5. Right? Be clear about this. Even if you want me to tell you normally, when you subtract in the decimal itself, okay, either it can be decimal or in the hexadecimal itself, if you take up, when you subtract 1051 minus 0036, 1051 minus 0036, so this would be what you are getting, minus 101b, 101b in the hexadecimal. Okay, this is what hexadecimal 10, that too you can observe, this is what 101b is the minus value, minus 101b in the hexadecimal. That minus 1b minus 101b, it is nothing else than in the decimal it is what, 4123. It is nothing else, in the decimal it is minus 4123. But my dear students, can you ever, anyone of you, can you remember and tell me what is the range of PC addressing? I had given this minus some value to the plus some value. Can anyone of you let me know in the decimal?
So minus 2048 to plus 2047.
Exactly, my dear students. So if at all, if you want any, like with respect to PC, any address in the PC, so we have a range which is minus 2047 to plus 2048. But here, don't you think that minus 4123 is even less than this minus 2047? So in this perspective, try to understand, my dear students, this is the instruction. Which instruction? This stch buffer comma x. In that, when you try to find out by using this operand address minus PC value, you are getting minus 4123, which is even less than the minus 2047. So it cannot be a PC mode. So for which P will be 0. For which P will be 0. What about the base relative then? If you ever remember, when it is not PC mode, When it is not PC mode, then how to find out the displacement? It is as usual, operating address minus the base address. I'll say base address, and we have the operand address as usual, which is 0036. What about the base address? What is the base address then? For that itself, if you see in the program, my dear students, here is the one. In this instruction you are defining the length into the base register. I repeat, you are defining length into the base register. So address of length is stored into the base register. What is the address of length then? Here you have to find out address of the length is what? 0033. I repeat, the address of the length is what? 0033. So my dear students, what does the base register has? It is the 0033. Students, are you understanding this point?
Yes, sir.
So what does the base register has? In the sense, it is the address of length. And what is that length? It is what is the address of the length? It is 0033. So in this equation it will become 0036 minus 0033, so which is nothing as 003. So I'll just say that simply 003. So here the displacement is nothing else 000 000 and 011, which is because 003 is the displacement. And for finding out this displacement, are you making use of PC or the base register? Definitely you are using the base register. So for which you'll be setting B as 1 and P as 0. So for which you'll be setting B as 1 and P as 0. So now if you try to find out the object code, you can observe this is what is this? It is what? 5 and followed by 0111, which is 7. Again 1100 is C followed by 003. Are you not getting this? 57C003. Students, did you understand how does you got the object code for this instruction?
Yes, sir.
Anybody has any queries, you can ask me. So in that perspective, I told you this STCH buffer comma X, which belongs to the base relative. Again, you have TXRT, it's a format to all this normal. Again, let me take you to this STX length. Okay, let me take you to this STX length instruction. Right, I'll take you to this STX length. In case of STX length, okay, in case of STX length, first let me find out the opcode for the STX. If I find out the opcode for the STX, you can see it is 10. How to write that 10? For that, before I move on to the STX length, so are you guys clear with the STCH buffer comma X?
Yes, sir.
Rest of the instructions which are common as same as rest of the instructions which are common as when we discussed in the previous example. So whichever is different, I'm just discussing those uniquely. Okay, and now I'm taking to the STX length. For this STX length, okay, for this STX length, what is the opcode for the STX? It is 10. How to rate that 10? How to rate that 10? As usual, it is 0001 and 00. It is 10. Again, you can observe. Again, you can observe it is neither indirect nor immediate. Even it is not using X register also. So what is going to happen? What is going to happen? N will be 1, I will be 1, X will be 0. It is not making use of any X register, and it is a format 3. So I will set as E as 0. Right? So this is for the STCH buffer comma X. Now, so as I'm working with the this STX length, as usual, first let me find out the displacement. How to find out displacement? You need to find out the length, address of the length. What is the address of the length? It is again, it is a 0033. What is the address of the length? It is 0033 minus PC value. What is PC value? It is 1059. I repeat, it is. So for this instruction, this story will become. Just make it out shorter. So this is for STCH buffer comma X. The same way I'll just write here for the STX length. Right, operand address is what? Address of length is 0013 and the PC value. What is the PC value for this STX length? It is 1059. You can observe 1059. When you write this 1059, it is 0033 minus 1059. It is as same as it is 1059 in the hexadecimal 1059 minus 0033. It is that is where you are getting as minus 1026. minus 1026. That is in the hexadecimal. When you convert that hexadecimal to the decimal, you are getting as 4134 minus 4134. Again, same way, this minus 4134 is 2 less compared to the minus 2047. Is it not? It is totally less than the 2047. So this also cannot be a PC mode. I repeat, this can also be a PC mode. So how about the base relative? However, we have operand address minus base. So operand address is here base 0033, and what would be the base address? The same story. What is stored in the base register? It is the address of the length. What is the address of the length? So it is 0033. So it will become 0033 minus 0033. You will get as 000. You will get as 00. And for finding out this address, you are making use a base register. So it is B as 1. So what is the object code? It is 1, 0011 is 3, and 01000 is 4, 000. That is where you are getting as 134000. Students, did you understand this for this STX length 134000?
Yes, sir.
Okay, so that's how I told you that this STCH buffer comma X is a PC mode, and STX length is also STX length and also STCH buffer comma X is also a base relative instead of the PC relative, right? The same way, when you work on this LDT length, okay, when you work on this LDT length also, it will be a same, it is a base relative. So only you can observe you are getting as 000. So instead of the PC mode, it is the base relative. In the same way with respect to LDCH buffer comma X as well, which is the base relative. However, I shown you here. So the same story which will be applicable for those as well. Students, are you understanding?
Yes, sir.
So for the rest of the other instructions, you can try out at your end. Okay, one thing is for sure, students, whatever the number of examples I'll be solving in the sessions, but until unless you start practicing, it will be difficult for you to understand and get it done. Right? So if you are done with the, or if you understood with the object code generation, then we'll take you to the object program writing. So in the object program, I hope you remembered what are all the different fields we have in the object program. It is the first field is the header record. First is the header record, and in the header record you'll be having H followed by the name of the program. Name of the program here it is copy, followed by the starting address is zeros, and the length I told you that last address is 1077 minus 1077 minus 0, it is 1077. So that's how you can observe H followed by copy, followed by zeros, followed by 001077. That is the header record. Then let us go for the writing the text record. From where exactly text record is starting? It is starting at the zeros, and you keep on writing. I hope this also we discussed in the previous classes. The maximum length of your text record, it can be 69 until you reach to the 69. So as we mentioned, it can be less than that as well, my dear students. It can be 67, 68, 66 as well, but at any point of time you should never exceed more than 69. So in that perspective, you just keep writing those object codes. And I even in the previous examples also I shown you how to find out the length of the text record as well. So this is the T followed by the starting address for this text record, and the length, how many object codes you have, or how many bytes of object codes you have in that text record, and you just need to keep writing. Here also you can observe. So till till here, which is 032010, till that first text record is done. Second text record we are starting at the 0F or 2016, but when you as soon as we reach to the 454F16, sorry 454F46, so then later we have a few set of reservation instruction, because this is where you'll be only reserving the memory space for which you don't have any object code. So the text record need to be stopped here itself, and you need to leave the space like this. Even though it is not reached to the 69, but you have to stop there itself and leave the space. However, in your program says that to leave the space. And further, next object code start, which is B410 starts at 1036. From there, again you need to keep on writing continuously. So likewise, right? So That's how you'll be writing the then you'll be writing the end record as well. So which is H, header record, T for text records. You in your object program you may have one header record and one end record, and in between you may have any number of text records. Guys, are you getting this point?
Yes, sir.
Now coming to the point, so here it is a M. Okay, M is the modification records. I repeat, M is the modification record. So how this modification record will be written, and what is the necessity of this modification record? Okay, how this modification record is written, what is the necessity of this modification record, all that I'll teach you in the next session. Okay, as of